Alright, hello everybody. My name is David Stitt, and I'm here on the UDL resource page that was linked in our week 2 instructions for EDCI 410. I'm kind of using this is my first experience with this Screencast program. I've had a couple drafts, but this is a pretty cool program, so here we go. So after kind of looking through the guidelines here and the examples and resources, I was trying to kind of follow the line that I set with my Google form, so I created a mock quiz for a Ag Tech 1 high school welding class. And that was kind of something I took in high school and something I'm passionate about and hopefully will teach in the future. So I was trying to find a resource that would aid in a class like that. So after checking a lot of these out, I stumbled across this checkpoint 2.5, illustrate through multiple media. So after clicking on that, I came across this page here, which has a whole bunch of resources that I checked out. Some of them are better than others, and finally landed at this MathOpenReference right here. So after selecting this, brought me to this page, which is MathOpenReference.com. And so as far as the principles that this MathOpenReference satisfies, if we go back to the UDL examples and resources, I would have to, I believe that principle 1 and 3 are satisfied by this MathOpenReference. The website completely provides multiple means of representation by giving students a different way to look at things, to look at everything from geometry to algebra. In a welding class, geometry is probably the big one, but it gives that second kind of second take as far as what's being taught in class. And then as far as multiple means of engagement, these kids, students I suppose, would not only be getting content through a lecture in their book and then shop demonstrations, they could also go online and kind of check out some stuff that they're supposed to be doing in class as far as angles and some different definitions like that, and have a different way to look at those. So moving on, if we go up to the MathOpenReference, kind of checking this out a little bit. So the first thing I really was drawn to was this plane geometry. With this welding class in mind, this is a big part of that. And so just kind of, if we click on this angles tab right here, it brings us to this page, and this has got a bunch of different sections to it, everything from relationships all the way up to types and measurements. So just checking out a couple of these tabs. So if we check out definition of an angle, pretty straightforward, a shape formed by two lines of rays diverged from a common point, or diverging. And it gives a little illustration here, and then you can kind of drag this orange dot around and see some different kind of angles. And I thought that was totally cool, a great way to illustrate kind of what an angle is, and you can visualize the degrees. And down here it's got some attributes, some different terminology used with angles and geometry, and some other really great stuff. So if we go back, just to kind of, I want to touch on how this program would minimize some barriers. I think this program this website would totally give a student a second means, outside of class time, to go in and review some stuff that maybe we need to use in a welding lab, on a project, that they could come in here and get some more some visualization of kind of what their project needs to look like. And I think that'd be an awesome way to kind of break down some of those barriers. As far as finding one of these that a student would totally utilize, so right here, if we click on the protractor, this is something that you could use. This is a hands-on tool that could be provided in a class. So let's say if you had to make a weld that was a 45-degree angle on one side, and then of course the other side would be 135 degrees. Right there, you can see it. It's right there. It's a great way to give a student a tool, and then it gives kind of some definitions on that protractor. And then just to check out what I was just describing, that supplementary angle, it's got a definition right here for that too. So if a student was confused, they could come in here and check that out and see right here. So let the illustration cycle through. So if we go to 45, you can see this is the 45-degree angle, and then 135 over here, and that's equals 180. It's a great visualization, and it's got some other cool resources down here. So anyway, thank you so much for listening, and I hope you enjoy. Thanks.